Hello, my name is Jax, and I'd like to show you today a demonstration for the formation of a rainbow. So, here we have a glass sphere which will model a raindrop. Although it is significantly bigger than an actual raindrop, that won't matter as long as it's spherical and lets light pass through it. To model the sun, we have a 35mm projector. Although, if you would like to do this demonstration on your own, a flashlight on phone will work just fine. We also have an adjustable aperture, which will eliminate any extraneous light that would pass through, fully illuminating the sphere. The light will come from the projector through the aperture and then bounce off the back of the sphere onto the screen. And that is why, when the sun is at your back, you'll be able to see a rainbow. Turn the projector on. You will notice a region of white light bordered by a rainbow with darkness on the outside. Now, using monochromatic filters, we can isolate the different colors. Now, to make this rainbow more visible, we have an illuminized patch on the back of the sphere, which will reflect any light that otherwise would have passed through back onto the screen. But of course, in real life, raindrops do not have such illuminized patches. So, rotating it, such that it no longer hits that, you'll notice the rainbow is now significantly dimmer, but reveals a different characteristic, its polarization. Using a polarizer, we can see that the light that forms the rainbow is polarized. Rotating it back so that it is now on the illuminized patch, you'll notice that there is a double rainbow with the colors in the opposite order and quite dimmer than the original rainbow, a significant distance away. This is also seen in real life. Thank you. That's all I have for today. And I hope you remember this demonstration when you learn about optics in the future. Goodbye.